Now we are going to the fifth chapter of Maths 2, Coordinate Geometry. But to get this chapter, we must have to prepare ourselves. In the first 2 years, we have seen the number line. This is the number line. Suppose this is the origin, and then on the same unit we have plotted these points. Any point of this line represent a number, and we know how we can find out the distance between 2 points on number line. Suppose distance between P and Q. Then what we have to? Distance PQ. Then 2 minus into bracket minus 3, and that is 2 plus 3. This is 5 units. We know how to find the distance between 2 points on number line. But suppose we draw 2 number lines perpendicular to each other in origin. Then all the points on this plane are divided in 4 parts. Each part is called the quadrant. And in the anti-clockwise direction, we have given the number to each quadrant. This is the first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Now we have to see how to find the distance between 2 points in the first quadrant or any quadrant. Suppose A having coordinates x1, y1 and point B having coordinates x2 and y2. Then how to find out the distance between A and B? Very easy. If B having coordinates x2, y2 and point A having coordinates x1, y1. So this distance is x2 minus x1. In the same way, the distance between these points A and C, that is y2 minus y1. So coordinate of C are x2, y1. Using Pythagoras formula, we have to find out the distance between AB. So we can write this such as AB is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. This is called the distance formula and very important in this chapter. So distance between AB is under root in the first bracket x2 minus x1 bracket square plus y2 minus y1 bracket square. Understand? We are trying to solve the practice set 5.1. In the first example, we have to find the distance between 2 points. Look here, coordinates are 2, 3 of point A and coordinates of point B 4, 1. Suppose this is x2, this is x1, y1 and this is x2, y2. So distance between 2 points as per the formula AB is equal to x2 minus x1 bracket square plus y2 minus y1 bracket square. Putting the values, what we get? 4 minus 2 bracket square plus 1 minus 3 bracket square. So we get 4 minus 2, 2 square plus 1 minus 3 minus 2 square. Then square of 2, that is 4. And square of minus 2 is also plus 4. This is equal to under root 8 or 2 root 2. So in the same way, we have to find the distance between other points. In a second, point P having coordinates minus 5, 7 and point Q having coordinates minus 1, 3. Suppose these are x1, y1 and these are x2, y2. So distance between PQ under root in the bracket x2 minus x1 bracket square plus y2 minus y1 bracket square. Putting the values, what do we get? Putting the values for x2, that is minus 1 minus 5. So minus 5, it will get plus 5 bracket square plus y2 minus y1. This means 3 minus 7 bracket square. So minus 1 plus 5, it will get 4 bracket square plus 3 minus 7. We get minus 4 bracket square. So square of 4, 16 and plus square of minus 4 also 16. So we get under root 32 or 4 root 2 units. So in the same way, you can find out the distance between L and M, and you can solve the 4th, 5th and 6th example in your homework. In the second question, we have to find out that these points are either collinear or not. So just look here the coordinates of points A, B, C. Coordinates of point A, that is 1 minus 3. Coordinate of points B, 2 minus 5. Coordinate of point C, minus 4, 7. Suppose this is x1, y1, x2, y2, x3, y3. So AB distance between A and B, that is under root x2 minus x1 bracket square plus in the bracket y2 minus y1 bracket square. Putting the values, what do we get? x2 minus x1, 2 minus 1 bracket square plus minus 5 minus 3. Minus 5 minus 3, so it will get plus 3 bracket square. So what we get? 2 minus 1, 1 square plus minus 5 plus 3, that is minus 2 bracket square. So we get 1 square, that is the 1 plus square of minus 2, that is 4. So we get root 5. This is the distance of AB. Distance between B and C. Under root x3 minus x2 minus 4 minus 2 bracket square plus 7 minus 5 bracket square minus 4 minus 2, that is minus 6 bracket square plus 7 plus 5, 12 bracket square. So we get 36 plus 144, that is the square of 12. So sum of these 2 points, 2 digits, under root 180, that is 6 root 5, and distance between A and C, x3 minus x1. So minus 4 minus 1 bracket square plus 7 minus 3 bracket square. So we get minus 4 minus 1 bracket square. So that is 25 plus 7 plus 3, 10. So square of 10, 100, and we get under root 125, that is 5 root 5. So look here, AB distance is only 1 root 5 and AC distance 5 root 5. Adding these two distances, we get 6 root 5, that is the exactly the distance of B and C. Distance between B and C, that is 6 root 5. So these 3 points are only here. So we can write such as BC is equal to AB plus AC. And so the betweenness between A, B and C as such as B dash A dash C or C dash A dash B. Look at this example. In the same way, you can solve the other 3 examples. So just we have to stop here. For today it is sufficient.